Hi everybody, Mrs. Jennings here. I am intending to leave this for you on Tuesday, April 29th, so I hope you're having a great day. This is your review sheet for your quiz, which should be on Friday. So I'm going to go through, I know the answers are on it, but I'm going to go ahead and work through it with you just in case you've got any questions. Hopefully this will clear that up for you. Make sure that you know your formulas, right? So we're not going to give you those. So you want to be sure that you remember your 30, 60, 90s, your 45, 45, 90, those relationships. You also want to make sure you remember SOHCAHTOA. You want to be sure that you remember the interior and the exterior angle measure formulas. So we're going to go through all of that. But again, none of that stuff's going to be given, not on this quiz nor on your exam. So we want to be sure that you're practicing all of those things. Okay, so for the first section, part A, find the measure of each angle of a regular polygon. Again, we're making sure that we're watching for whether it says regular or not, along with the sum of the interior angles. Well, it's kind of backwards. You got to start with the interior before you can figure out each one. All right, so we're going to go ahead and count sides. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 sides. All right, so ladies and gentlemen, if it's regular and I want the interior angle measures, I take n minus 2 multiplied by 180 degrees. Now again, I've talked about it a couple times, but essentially what you're doing is from any vertice that you want to find, that this is going to be a really poor one, but the idea would be that from any vertice, I'm going to create triangles, which is why I multiply by the 180. So from this vertice, I would not connect the one immediately adjacent. It would be down here, and then I would just kind of continue around my shape. And so then because what happens is, as we go around, right, I exclude the sides on either side of it. That's why it's minus 2, right? Because the sides on either side would not create triangles. And so what I've done is I've created, if I had 11 sides and I really have 9 triangles, there are 180 degrees in every one of those triangles. And so assuming I've punched it correctly, it should come out to 1620 degrees. So the whole thing, right, the whole 11-sided 11-gon, that should come out to 1620 degrees. Now, as long as it's regular, I can take that 1620 and I can divide by the number of sides, because that should be the same as the number of angles, and that would get me each one of the angle measures. So if we take 1620 divided by, I guess you can't see that, divided by 11, that's going to come out to, oh, it didn't say how to round. So we'll leave it 147.27 degrees. Technically that repeats, but there we go. All right, same thing's going to happen then for number 2. So this one's a little bit easier to see in terms of those triangles. 1, 2, 3, 4. I've got a 5-sided figure. That's a pentagon. So if I choose one of my vertices, again, this would not create a triangle, so I wouldn't connect that one, but this one does. So here's 1, 2, and then my third one, right? So the number of sides minus 2 multiplied by 180. And so what we found is the number of triangles, right? So 5 minus 2, I have 3 triangles. They're each 180 degrees. So my whole shape should come out to 540. That's what should happen. And then again, if it's regular, 540 divided by 5, right? Because each one of these angles should be the same if it's regular. That should come out to 108 degrees. Okay, so this is the whole thing. This one is each. All right, if I have a 23-gon, right, that just means I don't have to draw all the triangles, which is fine. Number of sides minus 2 multiplied by 180. Sorry, I don't know what that was. Okay, so 23 minus 2, which means I really have 21 triangles. And 21 multiplied by 180, it's a number I definitely don't know off the top of my head. Looks like 3,780 degrees. So that would be the whole interior. If it's regular, then I take that 3,780 and we divide by the number of sides. So if I take it and I divide by 23, again, we didn't tell you how to round. Oops, sorry, divide by 23. So we'll go out to the hundreds, 164.35 degrees. If it happened to say, you know, don't round, again, use your math key. You can change that back into a fraction. It doesn't reduce, so we would just leave it. Okay, but we didn't tell you on this one. All right, then we're going to look down at section B. Find the measure of one exterior angle in each regular polygon. Now again, I can find exterior angles, but if I don't have any given, The only way that I can do it is if I know that it's regular, because then each one would have to be the same. Now, I just want to remind you that an exterior angle has to be a linear pair with an interior one. So this right here, that could be an exterior angle. Okay, again, it doesn't really matter whether I drew it here or if I put it on the other side. So again, if I extend the side over here, this one could also be an exterior. Now again, I would not use both. I can only have one at each vertice, but either one of those would be an appropriate exterior angle measure. The one that's created out here, if I call it Y, this is not exterior. I think I said it in another one of the videos I left you, right? This is vertical with an interior, but it is not actually exterior. In order to be an exterior, it has to be a linear pair with an interior one. So I just wanted to remind you of that. Exterior angles are always going to add to 360. So I'm going to have 360. If it's regular, I can just divide by my number of sides. So as I count up my sides, 1, 2, 3, 4, 5, 6, 7. So if we take 360 and divide by 7, that one's going to come out to, again, we did not tell you how to round. We'll go to the hundredths. 51 point, let's call it 43 degrees. All right, and that would be an exterior, so it would be either one of these. But again, I only get one at each vertice. All right, so the same thing then as we look at our next shape. I'm going to count my number of sides. 3. All right, so it looks like I have 11 sides, so I would take 360. We're going to divide by 11. And again, this one's going to come out to 32.72. That's going to keep repeating, but give or take, 32.72 degrees. Okay, and then our last one here, again, we didn't give you a picture, but we don't need one. Exterior angles always add to 360. I simply divide by the number of angles that there are. So 360 divided by 16, that's going to come out to 22.5. That one was exact, and that should match all of our answers on the side. All right, then we look at choices, or part C. So at the bottom, we're supposed to find the area of the regular polygons. Again, in our world, they've got to be regular because that's what we've been practicing. All right, so we're noticing a couple things here on this one. One, they gave you a side length and they gave you an apothem, right? So if I just kind of go ahead and draw this in here, right, those would be my triangles. So if I just take a minute and I put my triangles in here, right, we would notice that we have 1, 2, 3, 4, 5, 6. Now, in order to find the area, you can either find the area of one triangle and multiply by the number you have, or your other option, right, your area is equal to 1/2 and you multiply by the apothem multiplied by the perimeter. So on this particular shape, again, it's not going to matter, right? They gave you an apothem so you could find the triangle. Like, it doesn't matter. If I use just the apothem and the perimeter, I would have that my area is equal to 1/2. Your apothem is going to be 5√3. And my perimeter would be 10 6 times. So 10 times 6. There we go. Sorry. Now, I'm going to encourage, again, we did a poor job with the directions. I do apologize. If you can leave it in exact form, you need to make sure that you do that. So as we punch that on the calculator, again, treat it like you would if you had pi. We're going to punch everything except that root. So 1/2 times 5 times 10 times 6 is going to get you 150. So your area is going to be equal to 150 square roots of 3. We didn't give you units, but if we had, remember that it would be units squared. All right, as we look at this next one, again, we told you they were regular, so it should be an equilateral triangle. So you can do this a couple ways. You can either put it in the circle and you can find the apothem. Because it's equilateral, you can also just go ahead and drop an altitude. So you can do it a couple different ways. If I drop the altitude, right, each one of these angles would have been 60 degrees. So if we cut it in half, here's your 30. Okay, and so my goal is going to be to find this height right here. I'm not going to call it an apothem because it's not. Remember, the apothem is from the center of the circle or the center of your shape to one of the sides. So for us, like the apothem, it would be somewhere like right around here. And you can do it that way, but again, if it's an equilateral triangle, I don't know that you have to. All right, so as we look at this guy, again, I would have 30, 60, 90. I wrote 30 twice. Let's go ahead and fix that. All right, x, 2x, and x root 3. So I'm noticing, right, that across from my right angle, that's the 10. So here's my 10. So 10 is equal to 2x, which means that 5 is equal to x. If I go ahead and divide by 2. So here's my 5, and here's my 5 root 3. All right, so across from the 60, this is going to be the height. All right, so again, I didn't have to use the triangle on this one. You certainly could, but you wouldn't have to. So the area of my triangle is 1/2 multiplied by the base, which should be a 10, multiplied by my height, which was going to be a 5 root 3. Okay, so half of 10 would be a 5. 5 times 5 is going to be 25, so I'm going to have 25 root 3. Again, I don't have units, but if I did, it would be units squared. Okay, so again, just one way to do it. All right, and then if we look at number 3 yet, so we kind of draw some triangles in here. All right, so we've got 1, 2, 3, 4, 5, 6, 7, 8. All righty. They gave us an apothem. They gave us a side length. So we don't really even have to do much on this either. So the same thing, guys. We can go ahead, again, if I've got an apothem and I've got a side length, I can either go ahead and find the area of the triangle, or I can use the other formula, that 1/2 times the apothem times the perimeter. So whatever you'd like to do. So area is going to be equal to, let's go ahead and just do the triangle this time. So the area of a triangle would be equal to 1/2. Your base is going to be 12, and your height is going to be 16.5. Yes, my battery is low. Okay, 1/2 times 12 times 16.5. Okay, so one triangle is going to be 99. But we have 8 triangles, so if I want 8 triangles, I'm just going to do 99 times 8. And so I should get 792. Except that is not the answer that we have on the answer key. So I must have done something wrong. Let me think for a second. All right. Oh, look what I did, guys. There are 9 triangles. If I count my sides, look, 1, 2, 3, 4, 5, 6, 7, 8, 9. Look, I missed a triangle. Where did I miss it? 1, 2, 3, 4, 5. Ah, look right here. There are 9 triangles. That's why. So if we add another one to it, let's add another 99. That's where I messed up. There we go. There's your 891. So I did it right. I just can't count. Okay, if you need help on the back, go ahead, check out that next video. Hopefully it's going well for you, and you can count better than I can. Thanks, guys.